Good day, my dear grade 8 learners. I am Teacher Florence, your virtual teacher for today. Welcome to our first virtual classroom in Mathematics 8, where lessons on your self-learning module or SLM will be thoroughly discussed and presented to you. So sit back, relax, and enjoy our interactive video. The self-learning module that you are holding right now was written and developed by the Department of Education, Caraga Region. So let us give credit and heartfelt appreciation to the DepEd Caraga Development Team for this wonderful SLM that we will be using during our home-based learning. This module is Quarter 3, Booklet 1, entitled Describing a Mathematical System. Now kindly turn the page on introductory message given by the development team from DepEd Caraga region. Shall we read all together? Ready? Start. The self-learning module or SLM is prepared so that you, our dear learners, can continue your studies and learn while at home. Activities, questions, directions, exercises, and discussions are carefully stated for you to understand each lesson. Each SLM is composed of different parts. Each part shall guide you step by step as you discover and understand the lesson prepared for you. Pre-tests are provided to measure your prior knowledge on lessons in each SLM. This will tell you if you need to proceed on completing this module or if you need to ask for assistance through your facilitator or your subject teachers for better understanding of the lesson. At the end of each module, you need to answer the post-test to self-check your learning. Answer keys are provided for each activity and test. We trust that you will be honest in using this. In addition to the material in the main text, notes to the teacher are also provided to our facilitators and parents for strategies and reminders on how they can best help you on your home-based learning. Please use this module with care. Do not put unnecessary marks on any part of this SLM. You may use a separate sheet or the answer sheet given by your teacher in answering the exercises and tests. And read the instructions carefully before performing each task. If you have any questions in this SLM or any difficulty in answering the task in this module, do not hesitate to consult your teacher or facilitator. Thank you. Now, let's turn to page 1, the What I Need to Know part of this SLM. So we are now on the What I Need to Know. I want you to take note that this module was crafted for you to understand the skills in describing the mathematical system. Varied activities were designed and aligned based on the different skills needed to process the knowledge and the skills learned and to apply it in the real life setting or situation. So, after the end of this module, you are all expected to, number 1, describe mathematical system and its components. Number 2, determine axioms for real numbers. Number 3, prove statements about real numbers using a 2-column proof. And number 4, apply mathematical system in real-life settings. Now, I think you're all set to begin this module. But before doing so, I want you to turn your module to page 2 up to 3. The What I Know part. The What I Know part of the SLM will check your prior knowledge about describing a mathematical system. So what you know or what you do not know yet about describing a mathematical system will tell us how much you already know about the topic. Now get your pencil or your ball pen and be ready to answer the 15-item test. You are provided with an answer sheet. Now use that answer sheet to answer the 1 to 15 item test. I will give you 5 minutes to do so. Are you ready? Now you may begin. So time is up, your 5 minutes, and now. At the end of this module, you will still be answering a post-test where your score should be higher than that of your scores from the pre-test. So I guess you are all set now to begin lesson 1, describing a mathematical system. We are now in our first lesson on page 4 of your SLM. Have you encountered terms that are not clear or undefined? Why do you think is it necessary to define terms? Why do we need to be precise and concise in what we say or write? Are there times that you need to prove that your statement is true? Or are there times that you believe in the statements even without proof? In this module, you will be learning about geometry as a mathematical system and its parts. The concepts and the skills that you will learn from this module will help you when you want to logically derive at a certain result. So we are now on what's in of your module. So in this activity, we need to answer prove me true. Okay, prove me true. How do we prove something? When we prove something or when we prove a certain statement, you need to use direct proof or indirect proof. What is direct proof? What is indirect proof? So for direct proof, we need a two-column form. A two-column form there will be composed of the statement and the reason. So on your screen there, shall we use? Okay. So on your screen, as you can see, our direct proof must be composed of a two-column proof. Okay? A two-column proof. All right? Where this column is for the statement, while this one is for reason. Okay, for statement and reasons, you need to make a statement and of course give its valid reason. So this is what comprise our direct proof. We need a two-column form so that we can prove a certain statement. Is that clear, everyone? While the other proof, which we call the indirect proof, it is indirect proof because you don't need this two-column proof. You can directly state your statement or write your statement. You can write your statement followed by the reason. So whatever your statement must have a valid reason also. But you don't need here a two-column proof just like your direct proof. That's the difference between a direct proof and an indirect proof. So for direct proof, you can directly write your statement followed by a valid reason. But again, it does not need a two-column proof. Is that clear, everybody? Now let us go back to your activity prove me true. So in our activity prove me true, I highlighted our activity. Of course, it says that you need to prove something true or prove a statement to be true. So direction, prove that if A is equal to B and C is equal to D, then A plus C is equal to B plus D. You need to complete the table given there by filling in the statements or the reasons. That means to say what proof we'll be using to prove this activity. That's right, we will be using direct proof because we need the two-column form. One column for the statement, okay, one column for the statement here, and another column for the reason there. All right, so shall we work on this activity? Let us start with your given. Given if A is equal to B here, if A is equal to B and C is equal to D, we use if statement followed by then statement. If you can recall your lesson on conditional statement, in conditional statement, we use the if and the then. If statement is actually the given. That's right. The if statement or the statement that follows if is our given, while the statement that follows then is something to prove. Okay? Something to prove. Therefore, the if statement should be our hypothesis. The then statement should be our conclusion. Now, to make a statement, everyone, I want you to take a look at the given. This is where we get our statements. Our very first statement should be taken from the given. So, the given there is A equals B and C equals D. So, statement number 1, A is equal to B. What must be our valid reason? If A is equal to B, that's right. It is given. Okay? A is equal to B is given because it is there in our if statement. So we have already statement number 1 and its valid reason. Shall we do number 2? For number 2, it is actually a blank, right? But given that the statement is blank, but the reason says that we need to add both sides by C. Take note that A equals B and C is equal to D. If we add both sides by C, then our first statement should be A plus C. Shall we write C here? Can you see C? Or probably we can change the color. All right, again, we will write C. A plus C is equal to B plus C. I hope you can read what I am writing. Again, for statement number 2, it is a blank statement, but there is a given reason to add both sides by C. That means to say our first statement A equals B should be added by C to both sides. Therefore, we have now A plus C is equal to B plus C. Valid reason, we added both sides by C. So, statement number 2 is now complete. Then, for number 3, there is a given that C is equal to D, but our reason is a blank. Take note that C is equal to D can be found in our if statement. So it is given. That's right. C is equal to D is given. So the valid reason for that is given. You write in your answer sheet provided by your teacher, statement C equals D, the valid reason for that is given. Shall we go to statement number 4? For statement number 4 is a blank. But take note that in the reason column, there is a valid reason, and that is to add both sides by B. This time around, in statement number 3, we need to add both sides by B. So, shall we write B plus C is equal to B plus D. All we did was we add both sides by B. From the statement number 3, C equals D, we added both sides by B. Therefore, we have now a new statement, B plus C is equal to B plus D. Now, for statement number 5, take note that in our then statement here, we need to prove that B plus T, or rather A plus C is equal to B plus D. Therefore, in statement number 5, it is already something that we need to prove, or this is now our conclusion part. So for number 5, we are already in the conclusion part. Therefore, we can conclude now that A plus C is equal to B plus D. For what reason? For the valid reason is that we used addition property of equality. As you can see, everyone, our valid reason used the properties of equality. The properties of equality are very helpful when we need to prove a certain statement. So, there are so many properties of equality that we can use, one of which is the addition property of equality. As we go along with our lesson, we will be discussing the properties of equality, which in geometry, we can now call them, instead of equality, we can now call them axioms. And I will tell you later, as we discussed with our lesson, what is axiom? Why do we need to use axiom instead of equality in geometry? So, is the activity prove me true clear to you now? Again, to prove something or to prove a statement, we use statement and reason. And this is what we call direct proof because we use a two-column proof. On to our next activity. On page 5 of your module, what's new? So in this page, you will have another activity and it's titled Match Me. So you need to answer the question, what branch of mathematics deals with measurement, properties, and relationships of points, lines, angles, surfaces, and solids? To answer that question, of course, you need to match column A with column B to answer the question that I have asked you. Then, you need to write the letter of the correct answer in the box here. As you can see, we have here boxes with which corresponds to a certain number. Again, column A, there are numbers there which actually are equalities or actions. Then, you match these equalities or action to column B, to the letters in column B. Each letter shows equality or actions that corresponds to column A. If you find the letter of the answer, you have to write directly at the box that corresponds to its number. Shall we do number 1? Number 1 is commutative. If you can recall commutative property, what does commutative property says? You learned this when you were in grade 7. Commutative property says that we have commutative property in addition and commutative property in multiplication, where it says the order or the position of any addends does not affect the sum. While for the commutative property of multiplication, the order or the position of the factors does not affect the sum, the product rather. So, which among this letter in column B corresponds to commutative property? The answer is letter E. That's right. Here is the answer. Letter E. For letter E, that corresponds to number 1. So, it says there that A plus B is equal to B plus A. Remember, you just changed the position or the order of the addends A and B. A plus B is equal to B plus A. It does not affect their sum. The same goes with the commutative property of multiplication. A times B is equal to B times A. The position of the factors does not affect the product. Now, since E answers number 1, then we need to write letter E here. Letter E. Okay, I hope that you can read the letters as I use a creative pen tablet in working our activity today. Now, we have associative property for number 2. What is associative property? I will not answer the rest of the numbers because I want you to answer the remaining numbers so that you will be able to complete the box here. That will answer our question here. So we have a question here that needs an answer. If you can complete the box, that will answer this question. But I would like to discuss further the given equalities. That is just a recall of what you have learned in grade 7 actually. Number 2 is associative property. What does associative property says? It says that the groupings of any addends will not affect the sum. That is associative property in addition. While associative property in multiplication says that the groupings of the factors will not affect the product. So that is associative property if you can recall. What about number 3, reflexive axiom? Number 4, symmetric axiom. Number 5, we have multiplicative inverse. Number 6, we have addition axiom. which we used in our first activity earlier. Then number 7, we have a transitive action. I do hope that you can recall the equalities, the properties of equalities you have learned in grade 7. As we go along with our next page of your SLM, we will be discussing the different axioms and properties of equality. I'll give you time to complete your box, the answer in your box, so that you will know what is the answer or what branch of mathematics deals with measurement, properties, and relationship of points, lines, angles, surfaces, and solid. As soon as you complete these boxes or you know the answer to that question above, I want you to answer the guide questions that follows. There are 3 numbers. The first one, how did you feel about the activity? Number 2, were you able to form the word correctly to answer the question above? If not, why? Number 3, were you able to encounter these axioms in grade 7? Yes, of course. But I want you to answer honestly our guide questions, because probably some of you were not listening to your teacher when she or he is delivering this lesson in your grade 7. All right? So, your time starts now. So, you are done working with your activity in the What's New Match Me activity. Now, I guess you are ready to learn more on page 6 of your SLM. This time around, what is it? What is it that we need to learn in this module? Geometry has a big contribution in our society. It is the beginning of numerous easy and complicated designs of buildings, infrastructures, houses, churches, and many others. This implies that we apply to the modern world what Euclidean theorists in geometry have been given. Euclid of Alexandria, who lived in 300 before Christ, was known to be the father of geometry. He systematized the ancient Greek and Near Eastern mathematics and geometry. The mathematical system known as Euclidean geometry attributed to Euclid. Thus, Euclid is also known as the father of Euclidean geometry. And as described in his textbook, The Elements, a structure formed from one or more sets of undefined objects, various concepts which may or may not be defined, and a set of axioms relating to this object and concepts. To have a better understanding regarding the parts of the mathematical system, now let us discuss one by one the different terms. Let us start with the undefined terms. Undefined terms. Okay, so undefined terms. What is undefined term? These are actually terms that do not require formal definition, but it can be described. You can describe them how you see them. The terms are actually the base to define other terms. The undefined terms are used actually to define other terms like definitions, postulates, theorems, or axioms. These are the building blocks of other mathematical terms. So undefined terms is very helpful when we want to prove a certain theorem or statement. What are examples of undefined terms that doesn't need definition? The best examples are the point, line, and plane. Okay? We will now discuss one by one the point, line, and plane. Okay, on your blank screen, I want you to take a look at this. This is this is an example of a point. A point there, a point there is actually a dot. Okay, a tiny object, or it is a location in a certain space. A location where it cannot be seen by a naked eye sometimes. So it's just a location. In a varied or various spaces, a point is just a dot. Have you ever seen stars in the night sky? How do you see them? Stars at the night sky is actually seen as a dot, right? So it best describe a point. Now, point is said to be dimensionless. Why dimensionless? Because it has no dimension at all. It has no thickness. It has no length. It has no width. So this is our point. Now, if we will draw another point and connect the points together or extend in both sides, we will also extend here. Take note that we will extend our point and draw an arrow. The arrow will tell us that our set of points can be extended infinitely in both directions. We can have certain set of points in that direction. That's why we draw an arrow. The arrow will tell us that the points are infinite. Now, what do we call this figure now that is formed when two points are joined together? This is now what we call line. Okay, another undefined term which we call line. Take note that a line is extending on both sides, right? We extend on both sides. So it has an infinite length, but it has no width and it has no thickness. So when you want to describe a line, we can say that line is an infinite set of points where it has an infinite length, but it has no width and it has no thickness. Suppose we will draw another point here, and then we connect the point. Okay, there is now another in undefined term which we call a plane. Take note that our plane is a blank space. Okay, our plane is a blank space where is all set of infinite points is located in that particular space. So a plane is made up of infinite set of points, or It is made up of two or more lines. So these three, the point, the line, and the plane, are the best example when we say undefined terms. So again, we do not have a formal definition in point, line, and plane, but we can describe them as what we see them. Now, what about defined terms? From the word itself, defined, it has a formal definition. The terms there has a formal definition using these undefined terms. What are examples of defined terms? We have angle, line segment, circle. The terms or the phrase which makes use of undefined terms and previously defined terms and common words. Is it possible to know the meaning of the word without actually defining it? If it is, how can we do it? We can define the term by describing some of its characteristics. For example, what is a real number? We know that real number is an undefined term, but we can define it by describing its characteristic. That is, for any real number x, we say that x is a number that can be found on the number line and may be rational or irrational. The definition is necessary to successfully support the statement of a proof. What about axioms? Axioms, postulates. What about them? Axioms and postulates, actually, these two, the axioms and postulates are statements also that is assumed to be true even without proof. We accepted these statements. The axioms and the postulates are accepted even without proof. Whatever the statement in the axioms and the postulates are accepted even without true, one of which is our equality. The properties of equality, we accepted them even without proof. Try to consider the statements. The sun sets in the west. Do we need to prove that the sun sets in the west? The Philippines is found in Asia. Do we need to prove that Philippines is found in Asia? There are 7 days in a week. These statements are actually accepted even without proof. We don't need to give proof in order to accept these statements as true. On page 7 of your module, we have here the table for our axioms and the description. For axioms, again, we are accepting this even without proof. Axioms are generally statements used throughout mathematics, while postulates are statements that may be used to justify the statements in a proof. So our properties of equality in geometry, we use axioms. So for example, we have commutative property of equality. In geometry, we call it commutative axiom. Now for commutative axiom, as you can see on your module, it says that in commutative property of addition, the order or the position of the addends does not affect the sum. So A plus B is equal to B plus A. The sum of A plus B is the same as the sum of B plus A. No matter how you change the position or the order of the addends, it will not affect the sum. The same goes with commutative axiom of multiplication. A times B is equal to B times A. The position or the order of the factors does not affect the product. What about associative property? For associative property, or we call it associative axiom in geometry, Notice that in associative action, we use groupings as denoted by the parentheses. It says that the groupings of the addends does not affect the sum. Suppose we have the addends A, B, and C. A plus B plus C. We need to add two addends first, right? So therefore, you can choose to add A plus B first, and then you add plus C. The sum of that is the same as when you add B plus C first, and then you add A. Again, A plus B plus C is equal to the groupings of A plus B plus C. The sum is still the same. The same goes in associative action of multiplication. The groupings of the factors does not affect their product. So if we have A times B times C, you multiply first A times B, and then you multiply the product with C. Their product, is the same as when you multiply B times C first, and then the product will be multiplied by A. Again, in associative action for multiplication, the groupings of the factors does not affect the product. Let's go to distributive action. For distributive action, we have there A times the quantity B plus C. What do we need to do to apply distributive action? All we need to do is to multiply A with the factors or the addends inside the parentheses. You distribute A with the factors inside the parentheses. Therefore, A times quantity B plus C is equal to, you multiply A times B first, plus you multiply A times C. That's distributive property or distributive action. Now let's go to reflexive action. For reflexive action, a variable is equal to itself, or a number is equal to itself. If we have A, then by reflexive action, A is equal to A. If we have 10, then 10 is equal to 10. That's reflexive action. A number or a variable is equal to itself. Let's go to symmetric action. In symmetric action, if A is equal to B, then B is also equal to A. Transitive action. If A is greater than B and B is greater than C, then we can say that A is also greater than C. In your module there, we can say A is less than B and B is less than C. Then A is also less than C. The same goes if A is equal to B and B is equal to C. Then we can say A is also equal to C by transitive action. Let's go to addition action. By addition axiom, all we need to do is to add both sides of our equation. For example, if A is equal to B, then we can add C to both sides, and we have A plus C is equal to B plus C. That's addition axiom. You need to add to both sides. Whatever you do to the left side of the equation, you will do the same to the right side of the equation. We also have multiplication axiom. For multiplication axiom, if A is equal to B, then we multiply both sides by a certain number or a certain variable. Say we have A is equal to B, and we multiply C to both sides of that equation. Then we can say that A times C is equal to B times C by multiplication axiom. Let's go to the existence of additive inverse. When we say additive inverse, we need to add the opposite of a certain number in order to get 0. Again, additive inverse means we need to add the opposite of a certain number in order to get 0. For example, positive A. What must be added to positive A in order to get the sum of 0? So if A, shall I write here? If A will be added by the opposite of positive A, which is negative A, then the sum is 0. Now take note that additive inverse of addition is the opposite of it. Let's go to the existence of multiplicative inverse. What do we mean by multiplicative inverse? You need to multiply a certain number or variable in order to get the product of 1. For example, A. What should be multiplied to A in order to get the product of 1? Shall I write here? A will be multiplied by the multiplicative inverse of A is A raised to negative 1. What do we mean by A raised to negative 1? A raised to negative 1 is actually 1 over A. So, positive A will be multiplied by the multiplicative inverse 1 over A. Or in short, you multiply A by its reciprocal. The reciprocal of A is 1 over A. Remember, A means A over 1. Therefore, the reciprocal of A is 1 over A. So, the multiplicative inverse of A is 1 over A, or A raised to negative 1. When you get the product of A times 1 over A, that is equal to 1. You may cancel A here and the denominator A. So what remains of our equation is 1. That's multiplicative inverse. How about the existence of additive inverse? Additive inverse means what do we need to add to a certain number so that the sum is itself? So let's say we have A. What should be added to A in order to get a sum of A? Our additive identity for addition is 0. When you add any number plus 0, the sum is itself, right? If A plus 0 is given, then the sum is A. The same goes with multiplicative identity. What must be multiplied to a number or a variable so that the product is itself? Let's say we have A. What must be multiplied to A so that the product is still A itself? So we multiply A or any number or any variable by 1. The multiplicative identity of multiplication is 1. Any number multiplied to 1 is itself, right? So A times 1 is equal to A. Our multiplicative identity is 1. And the last one is trichotomy axiom. In trichotomy axiom, it says that A is less than B, or A is equal to B, or B is less than A. By trichotomy, A is less than B, or A is equal to B, or B is less than A. So these are the different axioms that we need to use in order to prove a certain theorem or statement. Now take note that theorem is different from postulates. Theorems must be proven to be true or to be accepted true. Theorems are accepted only if you prove deductively, meaning to say, we still need to use the two-column proof in order to prove a certain theorem. Now, kindly turn your SLM to page 8. Consider the illustrative examples given there. There are three statements that we need to find the proof. Okay? So, shall we start with number 1? Given x, y, and z are real numbers and x is greater than y. Prove that x plus z is greater than y plus z. So we are here now. Okay, we are here now. Statement and reason. We need this as our proof. Statement number 1 should be taken from the, yes, from here, from the given. So we can use the first statement should be x is greater than y. So statement number 1, x is greater than y. What is our valid reason? Our valid reason is it is from the given. Then we shall make statement number 2. Can we directly make a conclusion? Remember, we need to prove that x plus z is greater than y plus z. Can we directly go to the conclusion? Yes, because we have addition axiom as our valid reason. What does addition axiom says? That we need to add to both sides of our equation. If x is greater than y, then we will add z to both sides of that equation. Therefore, we have now x plus z is greater than y plus z. Reason, of course, is our, yes, addition axiom. So, we completed our proof for number 1. Shall we go to number 2 now? Number 2, given that negative 4 is equal to m, then we need to prove that m is greater than 4, than negative 4. So let's make our proof by using the two-column form. One for the statement and the other is for the reason. Shall we begin with statement number 1? Statement number 1, where do we get statement number 1? From the given. So negative 4 is equal to m. Reason given. Then we have to make statement number 2. What shall we do with statement number 2 given that we have statement number 1 here? By addition axiom, then we can add to both sides of this equation. So what shall we add to both sides of this equation? We will apply addition axiom. Yes, we need to add plus 4 to both sides of the equation. So negative 4 plus 4 is equal to m plus 4 by addition axiom. Then let us make statement number 3. You just apply the existence of additive inverse, meaning you have to simplify negative 4 plus 4, and that is 0, right? Okay, that is 0 is equal now to m plus 4. So that would be our statement number 3. Okay, reason, we apply the existence of additive inverse. Remember, for additive inverse, we need to add here in statement number 2 something that or any number that will make negative 4 be eliminated or equal to 0. So we add 4 to negative 4 in order to get 0. That's additive inverse. For statement number 3, we have existence of additive inverse. Let us make statement number 4. Then, by addition axiom again, we will add from statement number 3 here, we will add negative m to both sides of the equation. Why negative m to both sides of the equation? So that we can eliminate m in this equation. So we will add negative m to both sides. That's addition axiom, right? Then 0 minus m is equal to m plus 4 minus m. By existence of additive inverse, we can now write statement number 5, which is 0 minus m here is equal to negative m. And then m minus m is 0, right? So 0 plus 4. That is statement number 5. Okay, valid reason, we have the existence of additive inverse and additive identity because we added 0 here. Remember, the additive identity is 0. Then, shall we make statement number 6? Simplifying our statement number 5, then we have negative m is equal to 4. Okay, where did we get negative m is equal to 4? From statement number 5, because 0 plus 4 is equal to 4. So reason of that is by the existence of additive identity. Remember, we have to add 0 plus 4. By additive identity, we added 0. The sum is 4. Negative m is equal to 4. Then, by statement number 7, we can apply multiplicative axiom by multiplying negative 1 to both sides. That's right. We have to multiply negative 1 to both sides so that our negative m becomes positive. The target is to make our negative m positive. So we apply multiplication axiom by multiplying negative 1 to both sides so that negative 1 times negative m is also equal to positive 4 times negative 1. Now, by multiplication axiom, we can simplify now negative 1 times negative m. So sa statement number 8, that gives us m or positive m already is equal to negative 4. Reason? That's multiplication axiom. So have we proved that m is equal to negative 4? Yes, by multiplication axiom. So we completed our proof for number 2. Let's go to number 3. Given that 4 times 2x minus 3 plus 16 is equal to 5x plus 37. We need to prove that x is equal to 11. Meaning to say, we need to find the value of x. But by using the two-column proof, let us discuss one by one our statements and reasons. So, shall we make statement number 1? We will get statement number 1 again from the given. So, copy the given. 4 times quantity 2x plus 3 plus 16 equals 5x plus 37. So, reason? Given. Yes. Then we will make statement number 2. From statement number 1, all you need to do is to apply distributive axiom. Meaning to say, we will multiply 4 to the factors inside the parentheses. So we have to multiply 4 times 2x first. That gives us 8x in statement number 2. Then you also multiply 4 times negative 3. That gives us negative 12. Copy plus 16 is equal now to 5x plus 37. Reason, we applied distributive axiom. Shall we make statement number 3? That is to simplify our statement number 2 by combining similar or like terms. Okay, what are the similar terms there? We need to combine negative 12 plus 16. That would give us positive 4. So copy 8x plus 4 equals, copy 5x plus 37. So that is our statement number 3. Then we go to statement number 4. Make our statement number 4 by using the existence of additive inverse. Okay, by using additive inverse, we need to add 5x. Okay? We need to add negative 5x to our statement number 3. So 8x plus negative 5x, that will give us positive 3x plus 4 equals 5x plus negative 5x plus 37. So 5x plus negative 5x is 0. So what is left is 37. So statement number 4, we have 3x plus 4x, 3x plus 4 equals 37. So meaning to say, we just have to apply the additive inverse in statement number 3. Then, to make statement number 5, we need to apply again additive inverse in statement number 4. So we need to add. What do we add in statement number 4? So that 3x will be left. Yes, we will add negative 4 to both sides of our equation. So we will add plus negative 4. Then we can have 3x. Okay, we can have 3x plus 4 minus 4. Okay, is equal to 30 equals 37 plus negative 4. Alright? Then, for statement number 5, we have now 3x, 4 plus negative 4. That gives us 4 minus 4, and that is 0, right? So what is left now is 3x for statement number 5. And then 37 plus negative 4, that gives us positive 33. So statement number 5, 3x is equal to 33. That is reason, existence of additive inverse. Then, shall we make statement number 6? For statement number 6, we need to apply multiplicative inverse so that we will eliminate 3 from our statement number 5, 3x equals 33. We will eliminate 3 so that x will be left. So what do we apply? To eliminate 3, we will multiply both sides by what? By 1/3. That's right. We will multiply 1/3 times 3x equals 33 times 1/3. So, 1/3, okay, here, we will eliminate that. Okay, 1/3 times 3x, that gives us x. So for statement number 7, x now is equal to 33 times 1/3 is equal to 11. So number 7, x is equal to 11. Again, where did we get x in statement number 7? We multiplied. In statement number 6, we multiplied 1/3 times 3x. That gives us x. Okay, remember, we will eliminate the denominator 3. And now, oftentimes, we fail to recognize that we are dealing with mathematical system in our lives, in our day-to-day existence. Now, here are some of the examples that show us how mathematical system is applied in the real-life setting or real-life situation. Page 9 of your SLM, there are 3 given examples there of a real-life setting. That is where we applied our mathematical system or the different axioms that you have learned. So for number 1, let us read. When I buy 2 pieces of shirt for 250 pesos, 1 piece of pants for 500 pesos, and a pair of shoes for 1,000 pesos, how much money will I need to pay to the cashier? So what comes in your mind is, what are you going to add first? Will it be the t-shirt plus the pants? You add them together, get their sum, and then you add the sum to the pair of shoes. Or you can add first the pair of shoes and then the pants, and then you add their sum to the t-shirt, to the price of the t-shirt. So from that given situation, we can see that no matter how we change the order or the position of what we're going to add, the result is just the same, right? No matter you add t-shirt plus pants first and then add it to the shoes, or you add shoes plus pants and then the sum will be added by the t-shirt, the sum is still the same. So what axiom did we apply to that? That illustrates associative axiom. The, the groupings of what we added first does not affect the sum. So that shows or that illustrates associative axiom for number 1. So without you knowing it, when you go to shopping, you apply the mathematical system. Number 2, Justin and Alan wanted to buy a gift for their mother during her birthday. Justin has 150 pesos savings and Alan has 80 pesos. If they double the amount, it would already be enough for the gift that they plan to buy. How much money would they need to have all together for them to be able to buy a gift for their mother? So as you can see there, Justin's saving plus Alan's saving. If they double the amount, we just have to multiply times 2, right? So as you can see, okay, we multiply the amount times 2 to the total sum of their savings. And that gives us, if you multiply 2 times 150, that is added by, we multiplied 2 times 80. If you get the sum altogether, 2 times 150 is 300, right? And then 2 times 80 is 160. You get the sum of their savings. The total now is 460 altogether. So if we add their savings all together and multiplied by 2, notice that the answer is the same. This illustrates what we did earlier here is we applied distributive axiom. for our statement number 2. For number 3, Ivy and Mary wanted to have the same number of notebooks this coming school opening. Their mother bought them 5 pieces each. They wanted to have 3 more, enough for the 8 subjects. How many notebooks will their mother buy so that they would still have the same number of notebooks? Show the step-by-step process using the 2-column form. So using the 2-column form, we will make 1 column for the statement and 1 column for the reason. Okay? For the first statement, as given there, both Ivy and Mary have 5 notebooks. Ivy has 5, Mary has already 5 too. So given, that's the reason for number 1. Now, for statement number 2, because they wanted to have 3 more so that it can accommodate 8 subjects. So what we're going to do is to apply from Ivy's notebook, which is 5 plus 3. And then for Mary, we also added 5 plus 3. What axiom did we apply for statement number 1? So we applied addition axiom. 5 plus 3, Ivy got 8 notebooks, while Mary also 5 plus 3 got 8 notebooks also. So in this situation, for number 3, we applied addition axiom. So as you can see, the different mathematical system is applied to our day-to-day life. Now it is time for you to answer what's more of your SLM on page 10. There are 3 given activities there. We have activity 1, figure it out. So what we're going to do in activity 1 is to determine the axiom that justifies each of the following statements. On your the answer sheet given to you by your teacher, I want you to write your answer there. Okay? All you need is to determine from numbers 1 to 5 which axiom justifies each statement. So answer numbers 1 to 5. Okay? Then proceed. After you're done with activity 1, proceed with activity number 2, fill me out. What you're going to do for activity number 2 is to prove each statement by supplying reasons in the 2-column proof provided in your answer sheet. You have the given 7b minus 25 equals to b. You need to prove that b is equal to 5 or the value of b is equal to 5. So use there the given proof for statement and reason. You need to supply the reasons. Okay? For number 1, it is already in the given. So you are already blessed that number 1 has an answer. And of course, statement number 1 is taken from the given. So the reason for that is given. Now for number 2, down to number 6, you have to supply the reasons. And if you are done with activity number 2, you may proceed to activity number 3, solve me. Okay, what is activity number 3 all about? So given a problem there, write your answer on the answer sheet. Again, you are provided with an answer sheet by your teacher. Write all your answer in the answer sheet. So, given Maria is solving 1 over x equals 1 over 2 minus 3x. Her next step is 2 minus 3x equals x. Now solve for the value of x and state the axioms that justifies it. Again, for activity number 3, you make your 2-column form proof. You make a proof, okay, to justify the step done by Maria in problems number 3. Okay? So, I'll leave you to it to make a 2-column proof for activity number 3. You may begin. After going through with everything in this module, it is now time to check what you have learned from the given activities, previous activities that you have done. Okay? So, given on page 11 of your SLM, in the box there are the different terms like undefined terms, axioms, defined terms, postulates, and theorems. From there in the box, I want you to fill in the blank using the correct terms that can be found inside that box. So, mathematical system, there is a statement there and there are blank numbers that you need to fill in. Again, use the terms inside the box to fill in numbers 1 to 5 in our mathematical system. That is test A of our what I have learned. Now, if you are done answering test A, you proceed to test B. For test B, that is true or false. Tell whether each of the following statement is true or false. You may write true if the statement is correct and false if it is not. Use the answer sheet given to you. So you may write directly your answer a true or false before each number. You may now begin. It is now time to apply the concept that you have learned in describing the mathematical system. Read the situation below and answer the questions that follow. So there are 5 questions below the situation. I want you to read the situation first carefully. Shall we begin? A sari-sari store owner bought 5 different brands of detergent powder, namely A, B, C, D, and E. He bought 20 pieces for each brand. Even at a glance, he can easily state which brand of detergent powder is the best seller. Now, each powder claims that it would not irritate the skin after using it. In this case, the store owner wants to test each brand to prove if the claim is true. So, on your answer sheet provided by your teacher, I want you to give your answer to the following questions. Number 1, what represents or describes the undefined terms in the situation? Number 2, what statement represents an axiom and why? Number 3, what statement represents a theorem? Justify your answer. Number 4, suppose a variant will cost 2x minus 5 equals negative x plus 10 pesos. Prove that each will cost 5 pesos. Use a 2-column form as a proof. Again, for number 4, you make a 2-column proof. For 1 column for the statement, second column for the reason. Number 5, suppose A, B, C, D, and E represent the number of packs of detergent sold for each brand. How much will the sari-sari store owner earn in total if the cost is 5 times A plus B plus C plus D plus E pesos? Use again a 2-column form for your proof. 1 column for the statement, another column for the reason. Now, you may begin. After doing every activities given to you in this module, I want you now to turn your SLM to page 13, 14, and 15. This time, you will be answering the post test. You are given 15 items. Okay, this time, let me remind you that your score here in the post test should be higher than your score during the post test at the pre-test earlier. Okay, remember in the post test, the same questions, but this time you have already filled with a lot of knowledge in this module. So we are hoping that your score here should be higher than your score in the pre-test. Okay, I will give you 5 minutes to do so. Again, use the answer sheet provided by your teacher to answer the assessment on pages 13, 14, and 15. So, you may start. Now, I presume that you have already finished your answering your post assessment or your post test. In addition to what you have learned in this module, I want you to do additional activity. So only one activity, letter A, complete me. For complete me, here's what you're going to do. Find the value of x and show a proof in a step-by-step process using two-column form. Given 5x minus 10 equals 3x minus 2. So write your statement and then the valid reason for every statement. So there are already 6 statements that needs 6 reasons also. So on your own, I want you to complete activity A. You may start. So I presume that you have completed now module 1. Answer key will be given to you by your teacher so that you may verify your work if they are correct or if you need more activities, if you need more lesson on describing mathematical system. So, you are also provided there with a note and a question. There are 3 questions provided for you there. You answer honestly because there we will know if you have learned in our module today about describing a mathematical system. So I hope you have learned so much through this interactive video and we have been able to help you in answering your activities in module 1. Okay, expect another video so we can help you with your module 2. Thank you everybody for watching our video. Good luck and see you in our next video. Goodbye everybody. Goodbye.